Hello, myself Naveen Kumar Saini. So in EMFT in the lecture number 4, so as we have briefed about the coordinate systems, because I want to continue with this topic, coordinate system and the transformations. So in the last lecture we have started the what is a coordinate system and what are different types of the coordinate systems, right? So orthogonal and the non-orthogonal coordinate system as we discussed. Then and we have started the orthogonal coordinate system, right? So the basic definitions we have covered. In that, the first orthogonal system is the Cartesian coordinate system, in which we have started that the range of variables, that is x, y, z, is minus infinity to plus infinity. Then we said about the vector A, that is a Cartesian coordinate. This vector can be represented at ax, ax, ay, ay, az, az, right? And we can represent this into the point where this is the point P, where the P is the x, y, z, right? This is the point, and second is the component. And what is the component? Component is ax, ay, and az. Then we discussed about the cylindrical coordinates. In that, again the two things are required. First is the point, second one is the component, right? So vector component. So in this we can see that the point is P, that is rho phi z. What is a rho? Rho is the radial distance from the z axis, right? So this is the rho. Phi is the angle. Phi is what? Phi is the angle from the x axis, right? Horizontal. So we can say this is phi is the horizontal angle. And what is the horizontal angle? Like this. If this is the x axis and we are moving like this, then it is the phi. So this angle is the phi. Z is the, as usual, height of the cylinder. Then we talked about the variables in the vector form, that is a rho, a phi, az, az, where the magnitude of this one can be calculated as a rho square, a phi square, and az square. And in this, the dot products of this variable of these directions, a rho into a rho, a phi into a phi, az into az, that is equal to 1. As we know, this is the orthogonal in nature or perpendicular in nature. In that case, a rho, a phi, az, a rho will be 0. Next is the cross product of that. So in that cross product, a rho cross a phi will be equal to az, a rho a phi into az will be a rho, and the az cross a rho will be equal to a phi. Okay. Then we have started the transformations. So cylindrical transformations. In this transformation, first transformation is point transformation in the Cartesian to the cylindrical, right? So in that, so what is the transformations? Rho phi z, this is the output. So this will be in the left hand side, and x, y, z is the inputs. So it will be in the right hand side. It means these inputs are given. So how to find the rho? So as we said, rho is the length, radial distance. So this rho is, we can say, this is the rho, this is x, this is y. So rho will be the resultant of x and y, right? So we can simply write, if we want, we can write it as the rho, a rho is equal to, this a rho will be equal to this plus this. So x in the direction of ax, y in the direction of ay. Sorry, so this will be the ay. Okay. So if I want the result of magnitude of this equation, so rho will be equal to what? X square plus y square, right? So same thing is here, rho is equal to x square plus y square. Similar to that, phi is this much, so it will be tangential, tan inverse, phi will be tan inverse of y divided by x, and z is equal to z. Then x is equal to rho cos phi, y is equal to rho sin phi, and z is equal to z. So this is point transformation from Cartesian to cylindrical, and here this is the point transformation, we can say, because this x y z in the right hand side. Okay, so this is the output and rho phi z is the inputs, right? So it means that this rho phi z is given. So in this case it will be rho phi z, and that is equal to x, y and z. So this is the transformation from Cartesian to cylindrical. Okay, and this is what, this is the from cylindrical to Cartesian. Okay, so this transformation Cartesian to cylindrical, and this one is cylindrical to Cartesian. Okay, I hope this point is clear to all of you. Then in this transformation we have this concept of the vector transformation, in which the vector is ax, ay, az, and corresponding vector in the this is in the Cartesian coordinate. So this one is the Cartesian, this one is in Cartesian coordinate system, and this is in the cylindrical. Okay, cylindrical coordinate system. So if we want this type of transformation, so we required the matrix for that to solve this type of questions. Okay, so these are things which I have mentioned. Suppose vector A is given and I want the component, vector A is given and I want the component in the cylindrical. So in short we can say this is the transformation from Cartesian to cylindrical. So this is the Cartesian to the cylindrical. Is that clear? So it means what I require, what I need the arrow a, phi and az. So in this case I want the arrow. So arrow, how I can calculate the arrow? So arrow will be equal to vector A in the direction of rho. Do you remember component transformation, also component projection, right? So if I want I have the vector and I want that vector into any particular direction, so what I do, I simply multiply with that particular direction. So I want arrow, so arrow will be what? A into direction of arrow. If I want the a phi, then a phi will be A into direction of a phi. If I want az, az will be A into az. Similar to that, arrow is A into arrow. Okay, so in this what we will do, we will simply A is this much and we are taking the arrow. So this arrow will multiply inside. So this is ax arrow, ay arrow, az arrow. Then it means what we require now, we have the ax, this is the component which we are getting from here, ay from here, az from here. Now our main concern is ax dot arrow, ay dot arrow and az dot arrow. So in this case, if I want, just for example, I will take the one example. If I have ax dot arrow, so I want the ax dot arrow. So ax is in this direction, clear? Arrow is in this direction. So what is the angle between these two? Phi. So you know that ax dot arrow will be equal to what? This will be dot product, you are aware about that, ax arrow cos of angle between these two vectors, right? Because but by our what we have the unit vector. So in this case we have the angle between these two is phi, so this will be cos phi. So what is the value? The magnitude of unit vector is 1, so this is 1, this is 1, what left? Cos of phi. So in this case ax dot arrow will be cos phi. Similar to that we can find a phi dot arrow. So a phi dot arrow, ay dot arrow. So this angle. So this is what? This is a 90 minus phi. When this is 90 minus phi, so again you can take the a phi, ay and a rho cos of 90 minus phi. So this become the sin phi. Similar to that, az and a rho, because this az and a rho. So this az, or you can say this az and a rho are perpendicular to each other. So it means the angle between these two is the 90. So in this case cos 90 is 0. So simply you can put all this all together into this equation. So a rho will become ax into what is this? Cos phi. Ay into a rho is what? Sin phi. And az dot a rho is 0. So we can write a rho is equal to ax cos phi plus ay sin phi. So this is a transformation from Cartesian to the cylindrical. So same thing we have to do for the a phi and then az. I hope this point is clear to all of you. So whenever you apply this a phi and a phi, then a phi will become like this and az will become like this one. Same concept you have to apply, which we have discussed in the previous. So directions are required, that is very important. Cylindrical coordinate transformation. Okay. So in short, this formula which we have, this is the transformation from ax, ay, az to a rho, a phi and az. So in this case, in the right hand side, left hand side, the output will be there, a rho, a phi and az. In the left hand side, ax, ay, az is there. So what we have, if you remember in the previous slide, we have this one, ax cos phi, ay sin phi, right? So these terms we got it. And the next slide we got this, that a minus of sin phi, ay cos phi and az. So we summarize this one into a matrix form. So how to remember this matrix? Very simple. First thing is just write the cos phi, sin phi and 0. So how we got this, right? So this cos phi is the angle between the ax and a rho. This from this sin phi we got this angle from the ay and a rho. Okay. So simply what you need to do, simply write this and then take the differentiation with respect to phi. So when you take a differentiation with respect to phi, it will become minus sin phi and it will become cos phi and this will become 0. Now what you need to do, simply because phi terms are over, now you can write as 0, 0 and rest is 1. Similar to that, you can write the inverse of this one, because this inverse of this transformation. So for that one, what you need to do, simply take this one in the left hand side and this one in the right hand side and take the inverse of this one. So inverse of this matrix will be, the row will become the column and column will become the row. So in simple way, this one will become the like this will be like this one and this one is in this way. So in this way you can remember the matrix as well to do the numericals when you are facing this type of problems. Next is the spherical coordinate system. In spherical coordinate system, again two things are required. First is the point, second one is the vector. So in the point we have the r theta phi, and in the vector we will, a corresponding vector for this one will be what? If you know that vector a will be ar plus theta, a theta phi will be a phi. I hope this point is clear to all of you. Okay. So right now we will discuss about the what is the point. Point is the r theta phi. So this is a sequence as we have discussed previously. In Cartesian coordinate, sequence is x, y, z. In cylindrical coordinate, sequence is rho phi z, and in the spherical coordinate system, sequence will be r theta phi. So you have to keep this thing in your mind. Okay. So what is the r? R is the because this is a sphere, so r is the radius of the sphere. Is that clear? Okay. So second is the theta. Theta is what? Theta is the angle from the z axis downward towards the xy plane. So this is the vertical angle. Okay. Then phi is what? Phi is the same horizontal angle which we had discussed in the cylindrical coordinate system. So if this is the z axis, so this angle is the phi, horizontal. And what is the theta? Theta is the vertical angle like this. So this angle will be the vertical angle. I hope this point is clear to all of you. And r is what? R is this radius. Okay. So if we have this one sphere, and I am taking the one section of this sphere in one coordinate system, in the in one coordinate. So in this way, when we have the x, y, z in positive, so I have taken the section of from the sphere. So this point, this sphere looks like this, right? So in this, I want to locate the point P. Again, the sub P point. So this P point is nothing but this P point is r, theta, and phi. Okay. So what is r? R is the radius. This one, radius of the sphere. Theta, theta is the angle, as I said. This is the theta from the z axis, like this. This angle, vertical angle. Phi, for finding the phi is the same, where if you remember, in the cylindrical coordinate system, we have taken the projection from the point to the xy plane. The same thing we have to do in the spherical coordinate system. We at the sphere, we are locating the point P, and we are taking the projection, surface projection, onto the xy plane. So when you are taking the projection of the line, we are connecting in the xy plane like this. So on this xy plane, right, we will connect the from the origin to this point. Okay, so this angle from the x-axis is the phi angle. Okay, so this is the phi angle. Now, what is the range of this r, theta, phi? R is, because it is starting from the 0, so this will be go to the infinite. Theta, theta is the angle, vertical angle. So in this case, it is starting from here. It is 0. Now it is 30. It is 60. It is 90. And up to now, when you go back up to here, so this angle is the 180 degree. Again, in the reverse order, this angle will be decreased. Is that clear? So it means theta will be 0 to pi. And what about the phi? Phi is the same. It is starting from the z axis, and it is going 30, 60, 90, like that, 180 to 70, and then up to 0, or up to 360. So it is starting from here, it is going like this, and once complete cycle, it will become 2 pi. So that is why the angle phi is 0 to 2 pi. I hope this point is clear to all of you. Okay. So now come to the transformation or the vector form. So in this, first is the spherical coordinate, how it is representing AR, AR, A theta, and A phi, as I said previously in the previous slide. The vector A will become, of more of this, will be like this: AR square plus A theta square plus A phi square. Then AR, A theta, A phi, these small are the unit vectors. These are directions of all this. AR dot AR, same thing is there, right? AR dot AR, A theta dot A theta, A phi dot A phi, because these are the unit vectors. When you are taking the dot product of unit vector with itself, then the value will become 1. Why? Because this is the dot product, and the angle between these same vector is 0, and cos 0 is 1. So that is why this value is 1. When we have the A and two mutually perpendicular basis function or the unit vectors, so in that case angle is 90. So in this case, what will happen? Cos 90 is 0. So that is why this term will become 0. And again, when we have the cross products, so cross products, you have to remember the sequence, and this sequence is nothing but this is the r, theta, and phi. So in this case, this is corresponding to AR, this is corresponding to A theta, this is corresponding to A phi. So in this case, AR cross A theta will be equal to A phi, A theta cross A phi will be equal to AR, and A phi cross AR will be equal to A theta. Okay, the same thing is there. A theta and A phi, AR cross A theta will be A phi, A theta cross A phi will be AR, and AR, A phi cross AR will be A theta. So you have to remember in this way. Suppose we have the reverse order, so in this case this will become minus, like A theta cross AR will be minus of A phi, and so on. So you have to keep this thing in mind to understand all these things. Then we have the transformations. So spherical coordinate transformations. For that, we have to find what is the transformation. Maybe a transformation from Cartesian to cylindrical, Cartesian to spherical, spherical to Cartesian, or spherical to cylindrical coordinate system. So two types of transformations are there. First one is a point transformation and second one is the vector transformation. For the point transformation, first of all we will see that this transformation is from xyz to r theta phi. So we can say this is the Cartesian coordinate system to the cylindrical coordinate system. So for that, because we require the r theta phi, so in the right hand in the left hand side what we will write the outputs, that is the r theta and phi, r theta and phi. Okay, in the left hand side we require the xyz. So how to find that? What is the r? R is the radius of the cylinder or spherical sphere. So r is this one, and r is what? R is the resultant of x, y and z. So in this case we can write just for example I am writing here so that things will be clear to all of you. So this r ar will be equal to x ax plus y ay plus z az. Okay, so in short also we can write x ax plus y ay, we can write as the rho a rho plus z az, that is equal to ar. So r will be equal to under root of rho square plus z square, or in place of rho you can write the x square plus y square. The same thing is there. R is rho square plus z square, or rho square is x square plus y square. So r will be x square plus y square plus z square ka whole under root. So this will be the under root of that. I hope this point is clear to all of you. Then we have the phi. Phi is what? This is the phi. Phi is what? Phi is you can write as phi as the, again the same which we have in the cylindrical coordinate system, y divided by x of tan inverse. Tan inverse of y upon x. Then we have next is the theta. Theta is what? Theta is angle because this is the vertical angle. So in this case this is the base and this is the height. I hope this point is clear. For theta, this term, this is the base and this one is the height. Just like the tan inverse. Tan inverse, for the tan inverse, this was the height, this is the base. For the phi. For the theta, this is the height and this is the base. So in this case what will happen? Tan theta will be equal to the rho divided by this one, that is z. Rho upon z, or theta will be equal to rho tan inverse of rho upon z. So here we can write theta is equal to tan inverse of height, that is rho, and divide by z. So this is the theta. So you can see here. So what is the rho? Rho is nothing but the x square plus y square whole under root. From here we can get it and divide by z. So in this case theta is tan inverse rho upon z, or theta is equal to tan inverse and root of x square plus y square divided by z, and phi is tan inverse of y upon x. So in this way we can have the point transformations. This is from spherical to the Cartesian coordinate system. Spherical to Cartesian coordinate system. In this, the x will be equal to, this is the x, this is the rho cos phi. Okay, rho cos phi. And what is the rho? Rho is this one and this is parallel to this one, and rho is what? R sin theta. Okay, then in this case x will be r sin theta cos phi and y will be rho sin phi, r sin theta sin phi, and z will be equal to r cos theta. So very simple. Z is equal to r cos theta means this is the z, this is the z, and this is the r. So r cos theta. Similar to that, we can do the same vector transformation in the case of spherical coordinate system. So what you need to do, simply remember these terms, this matrix, you have to go through it. So from where we got this matrix? This is very simple. See, simply what you need to do, just take these terms, x, y, z, left hand side, r theta phi right hand side, take sin theta cos phi, sin theta sin phi and cos phi, just put it here. sine theta cos phi, sine theta sine phi cos theta. Okay, so just a second. Okay, sine theta, just take the from here, take the differentiation with respect to theta for this term, differentiation with respect to theta for this term, differentiation with respect to theta from this term, and you will get this one. Then theta is over, leave it. Now come to the phi. So just take the differentiation with respect to phi, you will get this term, differentiation with respect to phi, this term, differentiation with respect to phi, this one. Okay, so in this case what is happening, you are leaving the theta and you are differentiating the phi. Okay, so when we want the reverse of this transformation, so again you have to take the reverse of this, so it will become, rows will become the columns and the columns will become the row. So in this way the transformation occurs, and the last distance between the 2 points, very simple, d is equal to r2 minus r1. R2 is one of the position vector, x r1 is another position vector. Just take the differentiation and use this Cartesian this coordinate systems which we have discussed right now. Just put the values and you will get the distances between the 2 points. So this is the example. I will just suggest कि please go through it, and this is very simple, all the transformations which we have covered. If you're finding an issue, please you can message me. Okay, so I will try to explain you again. Okay, please go through it. Last is the constant coordinate systems surfaces, which is again the what is happening when we have the constant surfaces. Okay, so these terms we can take in the next lectures as well. So I hope these are very simple. In fact, I will suggest, because these are very important to understand what is happening when we have the different constant surfaces. Okay, so please go through it. If you're finding an issue, we can continue with it. Otherwise, I will take the next topic in the next lecture. Thank you very much.